All right. Hey guys, this is our last lesson of Unit 2, 2.3 notes, dealing with graphing in standard form and vertical and horizontal lines. After this, you will have a review because on Thursday will be your second test for the class, or quiz, I should say. Remember, any quiz, you can use one page, one side printer paper, write whatever you want on it, and you can use that on the test. You can also use a factor sheet and you can use a calculator. No phones, nobody. Write everything you're going to want on one page, one side. You can use that on the test. Our guest host today is, I believe it's Bernard. I know I'm butchering the pronunciation. Riemann. He was a German mathematician back in the 1800s. Prolific guy, got his name on everything that you'll see. He's really responsible for the study of like calculus. Like he has a lot to say in that. He also had, I think, differential geometry, as odd of a subject as that is. Another one of those like really, really smart people. You should go back, you should check him out, see what kind of stuff he did. What we are going to start with here, some objectives. We are going to recognize when a linear equation is in standard form. So really just knowing what standard form is and recognizing slope-intercept form, which is from our last page of notes. We're going to be able to differentiate between those two kinds of equations. We're going to be able to graph a linear equation that's in standard form. So now that we have this new form, how are we going to graph with it? And then explain to a partner the way that you can remember the difference in when we are working with horizontal and vertical lines. We're going to have two of them. How do you know when to use each? So it's kind of like the goal of this lesson, putting it together. So linear standard form, how to graph when in that format. We should probably write what it is. Standard form is capital AX plus capital BY equals capital C. Now that may look a little different than what we're used to. We usually use lowercase letters. We use capital letters here because A, B, and C are just going to be whole numbers. Whole numbers. Now, the proper term for it is an integer, but for the sake of what we're doing, just keep in mind that there's just going to be whole numbers, no decimals, no fractions. So you might see something like 2x plus 5y equals -10, something along those lines. We're just placing numbers for A, B, and C. And this is similar to the way we would have a number for M and B with slope-intercept. It's just another way of writing it. What makes this one different is that it's got the A, or sorry, not the A, it's got the X and the Y on the left side of the equation. If you separate it according to the equals here, X and Y, our variables, are both on the left side. So it's kind of a pain in the butt because you can't immediately graph it, but it turns out all of our linear equations, any kind that you come across, can be written in this format. There are certain equations that we can't do y equals mx plus b for, even though that one's the nice one to graph. We just can't use it sometimes. So this is the one that always works, even if it's a little bit grosser to do. So how to graph with it? We are going to add or subtract the x term, both sides of the equation, and I don't know if I can scribble or underline this hard enough. Do not combine it with what's on the other side. We have to cancel the x. We need to throw it over to the other side. But you are not going to be allowed to combine it with what's over here because this side will never have an x, whereas what we're moving does have an x. We talked about what like terms do. They never combine. This is one of those situations where we have to move it, but it just won't be able to combine. Step 2, you're going to divide both sides by the number in front of y. So divide both sides of the equation by the number in front of y. That you'll have to divide every single term by that. Sometimes we'll get fractions. We're going to see what we deal with in that case. Step 3, now that you've done this, it should look like it's in slope-intercept form, which as a reminder is y equals mx plus b. And we just had a whole page of notes. We graphed a bunch of problems that look like that format. So really, how to graph one in standard form, we're really just going to be changing it into slope-intercept form and then graphing that. There's other ways to go about it, but keep in mind we've got a scope that we need to work with. We only have 8 weeks. So it is what it is. So graph each of the following. This is in standard form because it's got an ax or 2x plus by or 1y equals c, which is -4. So our steps, first we're going to add or subtract the x term. What would make the most sense to cancel this 2x would be if we subtract 2x from both sides. That would allow us to cancel what's here. So if we minus 2x over there, we also have to minus 2x over here. Gotta slash that one out. Y equals, well, like I just said earlier, and I can underline a whole bunch of times, please do not combine. Don't combine those together. I can't mush together a -4 with a 2x. One of them has an x, one of them is a number. So I can't actually mush them. What I can do is just write them both down. I like to think about it like puppies and kittens. If I have a puppy and a puppy, I've got 2 puppies. A kitten and a kitten, I've got 2 kittens. If I have a puppy and a kitten, like I don't have anything. I don't have a better way of saying that. I just got a puppy and a kitten. I've got an x term and a number, so I'm just going to write them both down. And so the proper way to do this is to always make sure you write the x term first and the number second. That's just kind of helpful because in our format, mx is before the b. So our 2x should come before the 4. Now, step 2 says to divide both sides of the equation by the number in front of y. Well, we don't actually have a number in front of y, so we might as well ignore that and just go right into graphic. We're going to plot our y-intercept at -4, 1, 2, 3, 4. And then we have a slope of -2, which is -2 over 1. And so we go 2 down and 1 right. Keep in mind, pause this video as you need to practice for yourself, try things out. I'm just going to keep moving on ahead because I don't really have a good way to dictate where everybody's at. I can go down 2, right 1, down 2, right 1, down 2, right 1. And keep in mind, we can always put it in reverse and go up 2, left 1. We have our line. The next problem, 2x plus 5y equals 15. So this is another one where we will cancel the x term first. To do that, I'm going to minus 2x from both sides. Slashing that one out. I have 5y equals, again, we cannot combine those, so I'm just going to write them both down. -2x plus 15. Now this is one where I actually do have to do step 2. Step 2 said to divide by the number in front of y. In this case, the number in front of y is a 5. So I'm going to divide both sides by 5. So y equals, and I'm going to do each of these separately. I've got a -2 over 5, which I'm just going to write as the fraction -2 over 5. And I've also got a 15 over 5. 15 divided by 5 is 3. You may be tempted to write a decimal here, but if you keep in mind that the slope we're going to have as a fraction later anyway, just leave it as a fraction. If you can't divide the 2 by the 5, leave it alone. Don't make it harder than it's got to be. So we would make our first dot at 3. And a slope of -2 over 5. So we would go down 2, right 5. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. And we could draw our line. The last problem here, which I would challenge you guys to pause and attempt yourself before you see the answer. To cancel the x term first, we are going to add 3x to both sides. So we have 4y equals, can't combine these, so we have 3x minus 32. We have to cancel the number in front of the y. So this 4, we need to divide it away. Y equals 3x divided by 4 doesn't really divide, so you would just leave it as 3 over 4. And negative 32 does divide by 4. So you get a negative 8. Graphing this, 1, 2, 3, 4, 5, 6, 7, 8. We are going to begin at negative 8. And our slope is a positive 3/4. So we are going to move by a 3/4. That is 3 up and 4 right. So 3 up, 1, 2, 3, 1, 2, 3, 4 over, or 4 to the right. Up 3, 1, 2, 3, 1, 2, 3, 4 to the right. All right. So graphing in standard form is really a process of trying to convert it into slope-intercept form and then doing the work that we practiced in the previous page notes. The last topic that we need on the back side of the notes is how to graph a vertical or horizontal line. If you ever see just like x equals, so like x equals a number, that is going to be a vertical line. When you have y equals, so y equals a number, that is always a horizontal line. Now, keep in mind, vertical lines are the ones that go up and down. Horizontal lines are the ones that go left and right. So it can tend to throw people off because I'll say x equals, and I'll say that's a vertical line, but they're like, well, wait, the x-axis runs left and right. And the y equals is a horizontal line, but the y-axis runs up and down. It's almost kind of a good way to remember it, that it always does the opposite of what you want it to do. There's plenty of you guys that really hate math, and this is one of those moments where it's like, yeah, use that hate to your advantage. I hate this part. It's always going to throw me off, going to switch it up on me. Well, yeah, that's a good way to remember. Honestly, I remember this out of sheer hatred, just sheer rage. Like, why is x equals a vertical line? Because of course it is. Y equals a horizontal line? Yeah, sure, why not? That almost like sarcasm, angry, just kind of fit. Now, when we're graphing it, hopefully we'll find a less aggressive way to learn it. I learn through rage. Not everybody does. It says graph each of the following. X equals 7. According to what we just wrote up a minute ago, any x equals should be a vertical line. But a way to think about this, I'm asking, where is x7? Where on the graph could I make a dot that would have x is 7? Well, 1, 2, 3, 4, 5, 6, 7. There's the dot. There's the first dot that I could work with. And the only line that I could draw that wouldn't dip to the left or dip to the right would be a vertical one. Because if I go left, I'm going into other x's. If I go right, I'm going into other x's. The only way to maintain my 7, to stand perfectly at 7, is to draw a vertical line. And in any of these points, you could check. Let's say you checked right here. That coordinate is 7, 3. It's got a 7. You could do that for any other point along this line. They're all going to have an x value of 7. So whether it is through rage or trying to reason it out, you want to find a way to remember which one's going to be which. And I've had people tell me all kinds of different ways that fit with them. It's going to be up to you to find the one that makes the click. X equals -5. Well, where would x be -5? Over here at 1, 2, 3, 4, 5. Left 5. And the only line that I could draw that wouldn't touch any other x's would be a vertical line. Same thing for y, if we look at those examples. If y equals 3, well, the only feasible spot it does that is at 1, 2, 3. And then I would have a horizontal line so that I don't go up and I don't go down. I'm staying perfectly at 3. Same thing with -4. This one is at 1, 2, 3, -4, and then I go horizontal line for that. These problems are incredibly quick to do because you just need one dot and you draw a line. Problem is, a lot of people go to take this test, and these are the problems that they get wrong because it's so short, they forget to write anything for themselves on their toolbox, and they're just like, how do those work? So please, even though these seem really quick, do not underestimate them. Write something down for yourself. Do yourself the favor. So that is the end of this lesson. You should now be working on the homework assignment. After that, there is also a copy of a review for the test tomorrow. It's going to be the same thing that's looking on the test. Nobody should be surprised about what's on their test. All right. Make your toolbox, one page, one side. Write whatever you want on it. Good luck, everybody.